Question 1, Adina is saving money to buy a new computer. She starts by saving £5 in week 1. This goes to 5.25 in week 2, 5.50 in week 3, and so on until she has enough money in total to buy the computer. So we need to state with a reason whether this is an arithmetic or a geometric series. So we notice that there is a common constant difference, and this means that it has to be an arithmetic series. So we say that arithmetic series since we have a constant common difference. So as there is a constant common difference in the amounts. In IAL, we need to write down an expression in terms of n for the amount in pounds saved in week n. So we can draw up a table here. We simply say that we've got the week and the amount. So we start off in week 1 with an amount of £5. In week 2, it's 5 plus 0.25. In week 3, it's 5 plus 2 times 0.25, and I can easily generalize into week n, having 5 plus n minus 1 times 0.25 being the amount saved. There is no need to simplify here, so that's good enough to score the marks. And then given that the computer is costing $350, we need to find the number of weeks it will take for Adina to save enough money to buy the computer. Now we know that we need to come up with all the money, so this means that the sum of the first n terms must be at least 350. We know there is a formula for Sn. It's n over 2, 2a, and a is 5, plus n minus 1 times d, which is the 0.25. And this should be greater than or equal to 350. So n is the number of weeks. Now, if we expand and simplify within the brackets, we get n over 2 times 9.75 plus 0.25n greater than or equal to 350. So I will expand. I get 4.875n plus 0.125n squared greater than or equal to 350, and I will collect everything on one side. It's 0.125n squared plus 4.875n minus 350 to be greater than or equal to 0. I will use the quadratic formula to extract the critical values, so I need to show the method here. N is minus 4.875 plus minus the square root of 4.875 squared minus 4 times 0.125 times negative 350, and all of it over 2 times a, so 2 times 0.125. So the critical values that we obtain are 36.9 and negative 75.9. We know that this is a quadratic inequality. I solve this graphically. It's a smiley face. We've got critical values at negative 75.9 and 36.9. And this goes plus, minus, plus. We need to be greater than or equal to 0. And we also need n to be positive, so we must be here. And the first integer within the solution set is 37, and therefore I can conclude that we will need 37 weeks. In question 2, we are given the graph of y is 4 to the x, and we are being asked to sketch y is 2 to the x and y is 4 to the x minus 6. So first of all, for y is 2 to the x, we know it's gonna look a lot like the 4 to the x. However, it will be moving in a lower position than 4 to the x, will be somewhere here. Here it's gonna be like this. Okay, so they will still be cutting through the same place on the y-axis. That's 1 here. This is 1, and for y is 4 to the x minus 6. This is simply a translation of the given graph 6 units down. I will also need to determine the cuts on the axis. So for this one here, I will simply say that when x is 0, we get that y is 4 to the 0 minus 6. So it's 1 minus 6, which is negative 5. And for the cut on the x-axis, I will put y to be 0, which means that 4 to the x minus 6 is 0. So 4 to the x is 6. I'll take logs of both sides. Log of 4 to the x is log of 6. So x log 4 is log 6, which means that x is log 6 over log 4. Now the final thing we need to note is that the graph of 4 to the x has the x-axis as an asymptote. So when we draw 4 to the x minus 6, this asymptote will move 6 units down, and it's gonna be at y is negative 6. So let me draw this, let me put the cuts on the axis, let's see whether everything fits in place here. So there we are. With blue, we've got the y is 4 to the x minus 6, the cut on the y-axis at negative 5, the cut on the x-axis at log 6 over log 4, and then y is 2 to the x, cutting the y-axis at 1, being lower than 4 to the x on the positive side because it's increasing at a slower rate, and being above this on the negative. And then in B, we need to use algebra to find the points where 2 to the x meets 4 to the x minus 6. So we start by equating the two here. We've got that 2 to the x is equal to 4 to the x minus 6. I will actually write 4 as 2 squared. So this will give me that 2 to the x is equal to 2 to the x squared minus 6. This is a disguised quadratic in 2 to the x. So 0 is 2 to the x squared minus 2 to the x minus 6. I can factor this as 2 to the x minus 3 and 2 to the x plus 2. You can expand to confirm that we indeed recover this. So it's either the case that 2 to the x minus 3 is 0, which means that 2 to the x is 3, or 2 to the x plus 2 is 0, which means that 2 to the x is negative 2. This is rejected, it's not valid. You can never raise 2 to a power and get a negative answer. So for 2 to the x is equal to 3, I will start by taking logs of both sides. Log of 2 to the x is log of 3. So x log 2 is log 3. So x is log 3 over log 2. And this is the only solution here. We also need to find the y value because we were asked to find the coordinates. So to find the y value, I can say y is 2 to the x. We have already established that 2 to the x is 3. So the y coordinate is 3. And therefore the point P, which we were trying to find, has coordinates log of 3 over log 2, comma 3. In question 3, we need to prove that for all single-digit prime numbers p cubed plus p is a multiple of 10. We will do this through exhaustion. We've got p and p cubed plus p. Now the only single-digit prime numbers are 2, 3, 5, and 7. So 2 cubed plus 2 is 10, which is 1 times 10, so it's a multiple of 10. 3 cubed plus 3 is 27 plus 3, which is 30, so this is 3 times 10. 5 cubed plus 5 is 125 plus 5, which is 130, so again, a multiple of 10. And 7 cubed plus 7 is 343 plus 7, which is 350, so this is 35 times 10. So we have investigated on a case-by-case scenario, and we have found in every single case that we indeed get a multiple of 10. The only thing missing is a conclusion, which is pretty much whatever we were asked to prove. So I would say, hence, for all single digit primes, for all single digit prime numbers p cubed plus p is a multiple of 10. In II, we need to show using algebra that for n in the naturals, this means that n is a positive integer, then n plus 1 cubed minus n cubed is not a multiple of 3. So I will actually start by considering exactly what I'm given, the n plus 1 cubed minus n cubed. I could expand this to give me n cubed plus 3n squared plus 3n plus 1 minus n cubed, which is 3n squared plus 3n plus 1, which may be written as 3 times n squared plus n plus 1, which simply means that this is a multiple of 3 plus 1. So I need to state this explicitly. It's a multiple of 3 plus 1. Hence, again, once more, the conclusion for n in the naturals, we have that n plus 1 cubed minus n cubed is not a multiple of 3. Question 4 is a binomial expansion. We have to find in ascending powers of x up to the x cubed term the binomial expansion of 2 plus x over 8 to the power of 13. So we know that we start with the full power loaded on the first term, so that will be 2 to the power of 13 plus 13, choose 1, 2 to the power of 12x over 8 plus 13, choose 2, 2 to the power of 11 x over 8 squared plus 13, choose 3, 2 to the power of 10 x over 8 to the power of 3. Each time the power on the first term drops by 1 and the power on the second term increases by 1. The sum of the two is always the original power. I put everything on the calculator. I get 8,192 plus 6,656x plus 2,496x squared plus 572x cubed plus ... And then we need to use our answer to find an approximation for 2.0125 to the power of 13. I will start by finding the appropriate value for x to be substituted. So 2.0125 to the power of 13. I set it equal to 2 plus x over 8 to the power of 13, which means that 2.0125 is equal to 2 plus x over 8. So 0.0125 is x over 8, which means that x must be 0.1. So in other words, if I substitute x to be 0.1 in this expansion, this will be giving me an estimate for 2.0125 to the power of 13. Now this will be an estimate because I'm not taking into account all the terms, the full expansion. I'm only taking into account the first 4 terms. So 2.0125 to the power of 13 will be approximately 8,192 plus 6,656 times 0.1 plus 2496 times 0.1 squared plus 572 times 0.1 cubed, which is giving me an answer of 8,883.132. Now in C, we are being asked, without calculating the exact value, to state with a reason whether what we have obtained is an overestimate or an underestimate. Well, if you look at the expansion, it's consisting of positive terms. So the part that we have missed to match the exact answer is a sum of positive terms. So this means that our estimate here is an underestimate. So we need to write this down clearly. We say that the answer is an underestimate as the terms omitted are all positive. This means that the exact value is greater than the estimate. In question 5, we've got this graph here. It's the curve C2 and the curve C1. And we start off by being told that this is a table of values for C1. And we need to use a trapezium rule to estimate the area bounded by the curve C1. The line X is 2.5, the X-axis, and the line X is 4. So we're essentially going to be estimating this area here. We know that the trapezium rule is actually given in the formula booklet. So the area in part A will be approximately a half times the height of the trapezia, which is the difference between two consecutive values of X. In our case, it's 0.25. And then it's the first and the last Y value once. So in our case, it's gonna be the 5.453 plus 5, and all intermediate values twice, so 2 times 7.764 plus 9.375 plus 9.964 plus the 9.367 plus the 7.626. We put everything on the calculator and we get 12.33 units squared. Part B, we need to find this integral. Notice that we have a no limit, so we need to put a plus C at the end. So the integral of x to the 3/2 minus 3x plus 9 dx is x to the 5/2. We increase the power by 1, divide by the new power over 5/2 minus 3x squared over 2 plus 9x plus c. And then in part C, we need to find to one decimal place an estimate for the area of the region R. So this region here is simply the area enclosed by the two curves. So we can see that C1 is above and C2 is below. So I will be integrating C1 minus C2. So the area R is the integral of C1 minus C2 with respect to x, with the limits being the 2.5 and 4. So this will be the integral of C1 with respect to x from 2.5 up to 4 minus the integral of C2 dx with the same limits, the 2.5 and the 4. Now we have already found from part A that this is approximately 12.33, and for the integral of C2 it's what we have just found in part B. So this will be 2x to the 5 over 2 over 5 minus 3x squared over 2 plus 9x from 2.5 up to 4. So we will substitute the upper and the lower limits. We get 12.33 minus 2 times 4 to the 5 over 2 over 5 minus 3 times 5 squared over 2 plus 9 times 5 minus the lower limit substituted, so 2 times 2.5 to the 5 over 2 over 5 minus 3 times 2.5 squared over 2 plus 9 times 2.5. So this is giving me 12.33 minus 124 over 5 minus 17.0778 ... which gives me 4.6 square units. In question 6, it's a circle with the equation given here. We need to find the value of k given that the x-axis is a tangent to this circle. Well, we know that if the x-axis is touching upon the circle, that means that the y is 0, so x-axis means that y is 0. I substitute, I get x squared minus 6x plus k is 0. And for this to be a tangent, it means that the discriminant must be 0. So the discriminant of this quadratic is simply b squared minus 4ac, so minus 6 squared minus 4 times 1 times k is 0. So 36 minus 4k is 0. 36 is 4k, and therefore k is 9. We found the value of k. And then the circle meets the coordinate axis at the points R, S, and T. And we need to find the exact area of triangle RST. I start by replacing the k in the original equation given. It's x squared minus 6x plus y squared plus 8y plus 9 is 0. When x is 0, I will find the cuts on the y-axis. So when x is 0, y squared plus 8y plus 9 is 0. I will use the quadratic formula. It's minus b plus minus b squared minus 4ac over 2a. So this is giving results of negative 4 plus minus root 7. When y is 0, we get x squared minus 6x plus 9 is 0. So x minus 3 all squared is 0, which means that x is 3. And I can quickly sketch this to see what's going on. So we've got the y-axis, we've got the x-axis, we've got cuts at 3, at negative 4 plus root 7, and at negative 4 minus root 7. And we're trying to find the area of this triangle here. It's obviously gonna be the base times the height over 2. The base is this one here, and the height is the 3. So we can simply see that the area will be the difference between the two cuts on the y-axis. So it's gonna be minus 4 plus root 7 minus 4 minus root 7 times the height of 3 and all of it over 2, and this is giving 3 root 7 squared units. Question 7, it's a logarithms question. So being given this logarithmic equation, we need to show that we can obtain this cubic equation in x. So I will actually start by writing the original equation. We've got 3 log of 2x minus 1 base 3 is equal to 2 plus log of 14x minus 25 base 3. I will start by writing this as log of 2x minus 1 to the power of 3 base 3 is equal to 2 plus log of 14x minus 25 base 3. I'll collect the logs on the left hand side, so I get log of 2x minus 1 to the power of 3 base 3 minus log of 14x minus 25 base 3 is equal to 2, which means that log base 3 of 2x minus 1 and cubed over 14x minus 25 is equal to 2. So 2x minus 1 cubed over 14x minus 25 is equal to 3 squared. Now I will expand the 2x minus 1 cubed. It gives me 8x cubed minus 12x squared plus 6x minus 1, which is equal to 9 times the 14x minus 25. So 8x cubed minus 12x squared plus 6x minus 1 is equal to 126x minus 225, and therefore 8x cubed minus 12x squared minus 120x plus 224 is equal to 0. Dividing everything by 4 will give me 2x cubed minus 3x squared minus 30x plus 56 is equal to 0 as required. So we have recovered the cubic equation in x. And then in b, show that the negative 4 is a root of this cubic equation. I will start by saying let f of x be 2x cubed minus 3x squared minus 30x plus 56. Then f of negative 4 will be 2 times negative 4 cubed minus 3 times negative 4 squared minus 30 times negative 4 plus 56, which is minus 128 minus 48 plus 120 plus 56. This is equal to 0, and therefore x is negative 4 is a root as required. So I have shown the substitution of the calculations. Because I got a result of 0, this means that negative 4 is a root of the cubic equation. And then hence, using algebra and showing each step of the working, we need to solve the original logarithmic equation. I will actually start by saying that if x minus 4 is a root, this means that x plus 4 is a factor of f of x. So this will allow me to start the process of long division to simplify the original cubic. So we have 2x cubed minus 3x squared minus 30x plus 56 divided by the x plus 4. So we wanted 2x squared here, so 2x cubed plus 8x squared. I deduct, it's negative 11x squared minus 30x plus 56. We want the negative 11x, so minus 11x squared minus 44x. Again, we deduct. We get 14x plus 56, so we want a plus 14 here. we get a remainder of 0 as expected after all, and therefore we have that the original 2x cubed minus 3x squared minus 30x plus 56 is 0, can now be written as x plus 4 times 2x squared minus 11x plus 14 is 0, which can be further factorized into x plus 4, 2x minus 7, x minus 2. So this cubic leads to 3 solutions. X plus 4 is 0, which means that x is negative 4, or 2x minus 7 is 0, which means that x is 7 over 2, or x minus 2 is 0, which means that x is 2. Now, it doesn't mean that the solutions of this cubic, the 3 solutions, are also solutions of the original logarithmic equation. So if we just revisit the original, we know that the input of the logarithm should always be positive. So we want 2x minus 1 to be positive, which means that x should be greater than a half. And we also want 14x minus 25 to be positive, so x to be greater than 25 over 14. So going back to the solutions we obtained, the 3 solutions, we only get to choose those that are within the acceptable range. And obviously x minus 4 is not, so this is rejected, it's not valid. The other two solutions, are both within the acceptable limits. Question 8 is a trigonometric question. We need to solve in part I this trigonometric equation. We are in degree mode. So we've got 3 sine of theta plus 30 is equal to 7 cos of theta plus 30. We've got 1 sine and 1 cosine. The angle is the same. So it makes sense to start by dividing both sides of the equation by cos of theta plus 30. And this will give me a tangent of theta plus 30 on the left-hand side. So it's going to be 3 tan of theta plus 30 is equal to 7. So tan of theta plus 30 is 7 over 3. And therefore I use my calculator to extract the principal value. It's a shift tan of 7 over 3, which turns out to be 66.801 degrees. And therefore theta plus 30 is the PV, which is 66.801 plus 180K. So if I deduct 30, I get theta is 36.801 plus 180K. So if I put K is 0, I get theta to be 36.8. And if I put K to be 1, I get 216.8 degrees. In II, we need to show in the first part that the equation 3 sine cubed is 5 sine x minus 7 sine x cos x can be written in this form. So I will start by writing out the equation as it stands. We've got 3 sine cubed x is equal to 5 sine x minus 7 sine x cos x. I will collect everything on the left hand side. I get 3 sine cubed x minus 5 sine x plus 7 sine x cos x is equal to 0. I see there's a common factor of sine x. I'll take it out and I get 3 sine squared x minus 5 plus 7 cos x in the bracket. It makes sense to write sine squared as 1 minus cos squared in order to get a quadratic in cos x in the bracket. So it's 3 times 1 minus cos squared x minus 5 plus 7 cos x, and this is equal to 0. And therefore sine x brackets 3 minus 3 cos squared x minus 5 plus 7 cos x is equal to 0. and therefore we get that sine of x minus 3 cos squared x plus 7 cos x minus 2 is 0, and it actually makes sense to write this as sine x 3 cos squared x minus 7 cos x plus 2, in order to have the quadratic in the bracket starting with a positive quadratic term. So what I did, I just multiplied everything by -1, and therefore we can say that A is 3, B is -7, and C is -2. And then in B it says, hence solve the equation for x between minus pi over 2 and pi over 2. So we are in radian mode. We are between negative pi over 2 and pi over 2. We have that sine x is 0, or 3 cos squared x minus 7 cos x plus 2 is 0. So for sine x is 0, the principal value is 0, which means that x is 2 pi k, or x is pi plus 2 pi k. Whereas for the quadratic in cos, it factorizes into 3 cos x minus 1 brackets cos x plus minus 2, So either cos x is a third or cos x is 2. Now we can't have the cosine of x being 2, so we reject this part, it's not valid. And for cosine of x being a third, I use my calculator to get the principal value. My PV is shift cos over third. Remember, the calculator is in radian mode. This turns out to be 1.23096. So x is plus minus the principal value, so plus minus 1.23096 plus 2 pi k. Now substituting for k is 0 will give me the solution of 0 from this side, and if I put k 0 here, I get plus minus 1.23. So all in all, x is minus 1.230 or 1.2. Question 9, we've got a sketch of a square-based open-top box. The height is h as shown. The base edges have a length of L centimeters. We know that the volume is 250,000 cubic centimeters, and we need to show that the external surface area is given by this expression in terms of h. I will actually start by stating that the volume of this box is simply L squared h, and is known to be 250,000, which means that L squared is 250,000 over h, and therefore L is the square root of 250,000 over h. Now, to consider the external surface area, bearing in mind that we are looking at an open top box, we've got the base and the 4 sides, 1, 2, 3, and the one at the back, 4. So the total external surface area will be L squared, which corresponds to the base, plus 4LH. So this is 250,000 over h. This is the answer we got from before, L squared, plus 4 times 250,000 over h square rooted times h, which is 250,000 over h. Now the square root of 250,000 is 500, so this simplifies to 4 times 500 over root h times h, and therefore this leads to 250,000 over h plus 2,000 root h, because h over root h is simply root h in the numerator, which is exactly what I had to show according to the question. And then in part B, we need to use algebraic differentiation to show that S has a stationary point when h is 250 to the power of k. K is a rational constant to be found. So I will actually start by writing the expression for S in terms of h in this form. S is 250,000 h to the minus 1 plus 2,000 h to the half. So ds dh is minus 250,000 h to the minus 2 plus 2,000 times a half h to the minus a half. Remember that we're taking the power down, deducting 1 from the power. So this leads to minus 250,000 over h squared plus 1,000 over root of h. And this must be 0 because it's a turning point, it's a maximum. So this means that 1,000 over root h is equal to 250,000 over h squared. I will cross multiply to get that h squared over root h is 250,000 over 1,000. And therefore h to the 3 over 2 is equal to 250, which means that h is 250 to the power of 2 over 3, which matches the form in which we had to give our answer. Therefore k is 2 over 3. In part C, we're being asked to justify by further differentiation that the value for h we have obtained gives the minimum external surface area of the box. So we will start by finding the second derivative, that will be d2s by the h squared, which is negative 250,000 times minus 2h to the negative 3 plus 1,000 times minus a half times h to the minus 3 over 2, which gives me 500,000 over h cubed minus 500 over h to the 3 over 2. We will evaluate the second derivative when h is 250 to the 2 over 3. So we substitute, it's going to be 500,000 over 250 to the 2 over 3 all cubed minus 500 over 250 to the 2 over 3 raised to the 3 over 2. Put everything on the calculator, we get an answer of 6. It's greater than 0, and therefore we conclude that this is a minimum. Remember that if the second derivative evaluated gives me an answer which is greater than 0, then I conclude it's a minimum. If it was less than 0, then it would be a maximum. And I always need to explicitly compare to 0 in order to get the full marks for this part of the question.